Hello. I, in fact, will not be talking about mesh security. I'll be talking about some other stuff, but it'll show up a little bit at the end. I think I've just been sending mesh security as the title for all the talks that I haven't come up with a talk for yet, and they're like, oh yeah, that sounds good. No, but I'm going to be today. Thank you guys for coming. My name is Sunny. I'm one of the co-founders of a project called Osmosis, and we're going to be talking a little bit about how Osmosis will be interacting with the modular ecosystem. So a little bit of background for anyone who's not familiar with what Osmosis is. Oh, yeah, that's better. Anyone who's not familiar with what Osmosis is, we are a DEX built on the Cosmos SDK. We have all sorts of, we just launched, we have liquidity, swapping ability. We launched the contrary liquidity very recently. You can do all sorts of have assets from over 50 different blockchains on the Osmosis blockchain. We have over $100 million in liquidity. We have all sorts of like pro trading tools, like basically the most advanced developed DEX in the Cosmos ecosystem. And liquidity from all different places, both from within Cosmos and outside of Cosmos. Out of all of the assets, like 4 out of 5 biggest pools are from non-Cosmos native chains, right? And along with just the DEX itself, we have this ecosystem of applications really meant to build this like full unified DeFi experience on top. So, beyond just your basic spot trading, you have your margin trading, you have your perps, you have your launch pads, you have your fiat on-ramps, you have lending protocols. So basically a full integrated DeFi experience. Everything, the goal here is you go to Binance.com, you have all these trading tools, you have all this like things in one unified experience. Osmosis is going to provide that in a decentralized way. So, as by being this like liquidity center for the Cosmos ecosystem, we are sort of the center of IBC traffic today. So if you look at, on any metric by users or by IBC traffic, by volume, Osmosis is sort of the center of that and has found itself as this like IBC hub and liquidity hub of the Cosmos ecosystem. And so now, very soon, hopefully, we will have a new entrant to the Cosmos ecosystem, right? The Celestia blockchain will be launching. And as part of the Celestia blockchain launch, the goal of the Celestia blockchain node implementation is to be as simple as possible, right? Like, obviously we need this thing to, with Celestia, we're gonna have like this beginning of all sorts of like new modular chains and rollups building on top of the Cosmos ecosystem. And, there seems to be this like thing about like, oh, app chains versus modular, and like, I think this is like some weird dichotomy, because really the whole point of app chains is this idea of modularity, right? It's saying like, hey, we don't need to put everything into one blockchain. We can, break out what you need. Osmosis, we're trying to be a DEX. We can like say like, hey, we don't want to deal with bridging. We are going to completely outsource that. That's not our problem. We're going to go find someone else to work with. We're going to go work with the Axelar team or the Wormhole team, right? We're going to go outsource bridging completely. This is part of the modular idea, right? Or, if it comes to things like data availability, or like, if we need to base money, it's like, okay, we're not building that. We're going to outsource this. This is all, it's all modular. So, so what I was saying was, the goal of the Celestia blockchain is to act as this app chain and to be as simple as possible, because obviously, we got to run it on our Kindles and we got to keep the nodes as light as possible. And because of that, the Celestia code base is actually like very, very minimalistic. You'll see that it actually imports very few modules. Ishmael just talked about how like, how can we avoid adding a general purpose VM or anything to this chain. So the one module that it does have, though, one of the few modules that it does have, obviously, is the IBC module, which is great, right? And so this is this decentralized, this permissionless bridging protocol that allows you to send tokens, data, assets, anything between any IBC-enabled blockchain. And so IBC is growing. It is, built on the Cosmos SDK. There's other chains as well now. Now we finally have it on Polkadot. We have it on the Penumbra and Anoma stack. So, IBC is slowly growing. But with Celestia now and this ecosystem, the modular ecosystem that's being built on top, we have a whole bunch of new frameworks being built, right? You have like the OP stack now, right? You have Rollkit, you have the Sovereign SDK, you have Eclipse, and it's like, it is going to take us time to go and build out IBC for every single one of these, because the goal of IBC is to really like build in your bridging protocol at the same security level as your consensus system. It uses light client proofs, and it will take time for us to get there. Obviously, the goal is we want IBC everywhere, but and there are people working on this, right? Like Polymer is working on adding IBC, like ZK IBC to all of these sort of different stacks, but it'll take us some time to get there. And so right now, how do we do this? We're going to have to rely on other bridges, right? And so this is kind of where, so the question is, how will all these rollups and chains and sovereign rollups and everything on all these different stacks access liquidity, especially TIA liquidity, right? Because they need that TIA to pay for their data availability. How are they going to get that TIA to there? Well, this is where Osmosis comes in. So Osmosis is, really expanding on its bridging support. So obviously we support IBC today. We work very closely with the Axelar team. Wormhole just announced yesterday at OsmoCon that they're launching Worm Chain, which is going to be a Cosmos SDK-based chain. And then the important one here is Hyperlane, right? So Hyperlane seems poised to be the, bridging, the first bridge that's available to a lot of these different stacks because of the way that it's been designed as this, very modular bridging system where you can choose what kind of security system you want. And so we are working on adding Hyperlane to the Osmosis chain, because of its app-defined security model, we can write it as a COSM-WASM contract, and with this, we're going to be able to use Osmosis as the connector between Hyperlane and IBC. So now you have this flow where finally you can say, hey, how do you get TIA from Celestia onto something like Eclipse or onto an Eclipse-based rollup? Well, you can IBC from Celestia to Osmosis and then Hyperlane from Osmosis to Eclipse. And this will be, and the idea here is that we're going to use Hyperlane to connect to all of these sort of different rollups and get TIA onto them. Now, well, what do you do when you're at the center point of transportation routes, right? Well, you build a trading center, right? You build Constantinople, right? You're at the crossroads. You build a trading center there. And that's what we're building with Osmosis. So we want to be the place where we build up as much TIA liquidity and liquidity for the entire modular ecosystem and provide these services and like product that we've been building for the Cosmos ecosystem, but expand just beyond that. And so one of the things that I'm really interested in is like protocol-owned TIA, because if anyone remembers a couple of months ago, like the Arbitrum chain basically came to a halt because like some dev account didn't have enough ETH in it to pay its like data availability and stuff, right? So we should be moving to a world where no, you shouldn't be relying on some like foundation or some dev team to be like paying for your submission proofs to your DA to Celestia, right? You should be actually moving towards a system of protocol-owned TIA. And so, there's a bunch of different ways that we can do this. So one, we have this protocol called StreamSwap, which is basically a auction system built on top of the Osmosis chain. And I think a lot of the new projects that are launching can do these stream swaps. It gives you this initial distribution, but you can do it for TIA. So that way you have this initial distribution of your token, but now your protocol owns TIA in its community pool or treasury, and it can pay for its own DA without directly from itself. We also have built this thing for the Cosmos ecosystem called fee abstraction. And what fee abstraction is it's meant for transaction fees. So what you can do is you can take a chain like Stargaze, right? Stargaze is an NFT platform built on Cosmos. People can start paying their transaction fees in stars, but they can also pay their transaction fees in any token. They can pay in USDC, they can pay in Osmo, they can pay in Bitcoin. And what we've done with this fee abstraction module is Stargaze can accept these fees in all these different tokens, but what the chain will do by itself is it will send all the tokens to Osmosis, swap them to its own native token, and then send them back to the Stargaze chain so that way they can be distributed as fees or burnt or whatever they want to do. So this module is available. It's available on our GitHub. You can go to github.com/osmosislabs/fee abstraction. You can import it into your Cosmos chain today, and any Cosmos chain can start accepting fees in any token. Okay, what's the next step? The next thing that we're going to build with this is DA fee abstraction. How do you let all of these rollups pay? Let's say they don't want their own protocol-owned TIA in their treasury, but what you can instead do is say, hey, a chain like Manta can say, oh, we are going to hold our own native token, Manta, but we need to pay our DA. They can send it to hyperlane it to Osmosis. It will automatically swap it to TIA and send it to the Celestia chain in order to pay for the DA. And so we are working with some teams to actually build this out in production now. Another way that beyond just for fee abstraction, with this whole modular idea, a lot of these chains, we work very closely with the Argus team. We can build this idea of outposts where they don't have to build their own DEX infrastructure for their own chain. They can actually provide things like swaps and everything over IBC. So let's see if this works. This is a demo that we built of the Cosmos swap, which is basically, this is a swap on the Juno chain. You're swapping Juno for Osmo. You make a single transaction on the Juno chain, but what it's doing is it's actually sending the tokens to Osmosis, swapping them to to Osmo, and then sending them back to the Juno chain. So basically, Juno doesn't need its own native DEX. Let's say you have a DAO on Juno or whatever you're trying to do, you can tap into Osmosis's far deeper liquidity. And so the Evmos team has also built a similar version, similar concept for the EVM. The Skip team has, you saw them present an hour ago about IBC.fund. You can basically swap from any chain to any chain on any token on any chain to any token on any other chain over IBC, and we'll be working on integrating Hyperlane into the system as well. Yeah, all through Osmosis. Anyways, so these are some of the ways that Osmosis is planning on integrating more deeply into the whole modular ecosystem. One of the other things I'm actually really interested in is, obviously I do have to talk about mesh security and how we want to incorporate data availability into mesh security. So, the premise of Cosmos, and I think a lot of the thesis in a lot of the modular ecosystem is this idea that every chain is the L1 for its own internal state and an L2 for its foreign state, right? This is sort of the whole idea behind these sovereign rollups. And so, Osmosis is the settlement for the Osmo token, but it acts like an execution environment for any axle that is bridged IBC to Osmosis. And so as part of IBC today, we do these sort of light client proofs where two chains are going along. You send an IBC packet that includes some sort of light client proof. But what we want to do is eventually make IBC or the security model between these chains better than just light client proofs. We want to start to incorporate things like fraud proofs. And finally, now, thanks to things like Rollkit, we actually have fraud proofs for the Cosmos SDK. Now, the thing is, fraud proofs have this huge time delay to them, right? You have to wait the entire challenge period, and the UX that people have come to expect in Cosmos is very fast bridging, right? You can IBC between two chains in a matter of seconds, and that's sort of one of the things that people really love about it. And so we don't want to build in this, fraud-proof window into the IBC bridging protocol because it'll just massively deteriorate the UX. But how we can use fraud proofs is in mesh security. So mesh security is this idea of restaking where you can say hey, validators are going to give certain guarantees about they're going to be restaking their Osmo to. Yeah, okay, so, and as part of this, what we've done is, the initial version of mesh security is mostly about Tendermint fraud proofs, so it'll be able to detect, hey, okay, this validator did something malicious in the consensus protocol, we're going to slash them. But the way mesh security is implemented is actually as it has this interface called a slasher contract, and you can write arbitrary slasher contracts, right? You can do it for things like, we're going to do mesh security restaking for an Oracle protocol, and if one validator's Oracle price is too far away from everyone else, that is a valid slashing condition. What we can also do is build Rollkit fraud proofs as a slashing condition, right? And so I think that eventually every Cosmos chain will start to use rollkit-style fraud proofs, right? And so that's great, but then how do you make sure that you have these fraud proofs? The idea is that, like, okay, we're not going to block IBC bridging on it, but if a Byzantine state machine sends an invalid packet, in the future, they will be slashable for it. But to make them slashable for it, we need to make sure there's data availability. So this is what we can block for. We can at least block on data availability before accepting IBC packets. So let's say chain 1 or say chain 2 wants to send some assets to chain 1. What it can do is generate a transaction. It will post the data onto something like Celestia or any DA system, and the validators of chain 1 will be running a data availability sampling like client of Celestia. So in the validator software, we should be having this DAS, like client, built into the software. And then what they will do is when IBC data is sent from chain 2 to chain 1, the validators will basically use a vote extension to approve whether or not that they actually got they'll validate that the data is available. So they're not going to actually validate the fraud proof itself. They're just going to validate the data is available so that someone in the future can submit a fraud proof to the mesh security slasher contract if needed. Anyway, so thank you guys so much for listening, and I hope you learned a little bit about osmosis and mesh security and what we're building. Thank you.